Welcome back, class. Now let's talk about cognitive psychology. We'll be discussing such items as intervening variables, mental representation, the early influences on cognitive psychology, looking at individuals such as Chomsky and others, cognitive revolution, the ideas and concepts of artificial intelligence, Turing, Cartesian challenge, questions dealing with artificial intelligence, Turing test, and functionalism in cognitive science. Tolman's intervening variables. During the last session, we talked about Tolman somewhat. This idea of looking at behavior, but also talking about these things called intervening variables, something that deals more with a mental process that behaviors at the time were not really interested in doing. These intervening variables are hypothetical internal states that are used to explain relationships between observed variables, such as independent and dependent variables. Examples would include such things as learning, memory, motivation, attitude, personality, traits, and so on. The basic idea is this: you have some sort of independent variable, and then something goes on in the organism, an intervening variable that has some sort of impact on the dependent variable. He proposes that these intervening variables are going to be things like learning, memory, motivation, and so on. Things that we cannot truly see. So the hardcore behaviorists would have nothing to do with these things. So now cognitive aspects are part of the work of psychology as Tolman introduces this idea of intervening variables. So, an experiment by Tolman and Hanzik, 1930, on latent learning in rats. Specifically, the group that received a reward every time they reached the goal box. One of the independent variables was the number of practice trials the rats received. They got one trial per day, so each rat got an increasing number of trials. The dependent variable was the number of wrong turns or errors that rats made on a trial. The following graph shows a relationship between the independent variable and the dependent variable. So the independent variable, number of practice trials, the dependent variable, number of errors. We can see them sloping downwards from trial 1 to trial 17. The average number of errors starts off at 10 or around 9 or so, and then increasingly goes down and down and down. Theoretically, an internal state of, quote, learning intervened between the independent variable, practice trials, and the dependent variable, errors made. So, learning is the intervening variable. It was this state that caused errors to decrease, not the practice trials. So the practice trials did not cause an impact on the dependent variable, the number of errors. What did cause it is learning, an intervening variable between independent practice trial variable and the dependent variable of errors. So the intervening variable and operational definitions. Intervening variables are studied by means of operational definitions, which are descriptions of procedures that are assumed to have some link to the internal state. So we have the operational definition, we have the practice trials, the independent variable. All right. The intervening variable, learning, takes place, and then the operational definition of the dependent variable here are going to be the errors. So errors being reduced because of the practice trials, but really it's because of the intervening variable, the learning that's taking place within the organism. Now, mental representation. An internal state of an organism that reflects or mirrors actual or possible states of affairs in the external world. Tolman would call it sort of a cognitive map. So we have sensory input, okay, that leads to some sort of abstract forms. Local features such as colors, lines, Orientations can be embellished or extended, transformed into abstract information, representations, and actions, and so on. We have mental representation of these. They can also interfere, like in the Stroop task. Now, Posner had a letter matching task. Are these letters from the same category of vowels or consonants, or are they different? He transformed into an abstract information representation. The Stroop task is, again, name the color in which the word is printed. That is, don't read the word, just say the color. Red. Red. Okay? The idea here is that we will be having some sort of conflict, interference, because we see red, the word says red, but the color is going to be different. So, what are some of the early influences? History and contributors. Throughout psychology's history, human cognitive abilities have been studied philosophically and later experimentally. The contribution of J.S. Mill, Sir Frederick Charles Bartlett, Fechner and Ebbinghaus, James and others have been discussed earlier. Jean Piaget. His work demonstrated that the child's interactions with the environment become more complex and adaptive as its cognitive structure becomes more articulated through maturation and experience. His work in cognitive development between the 30s and the 40s contributed to the revived interest in cognitive issues in the 50s. Cybernetics. Cybernetics is the study of the structure and function of information processing systems. Shannon and Weaver began what is known as information theory, which notes that the various transformations of information undergoes as it enters a communication system, as it operates within the system. Noam Chomsky argues that the human brain is genetically programmed to generate language. Each child is born with brain structures that make it relatively easy to learn the rules of language. He referred to this as the language acquisition device, the LAD. The LAD exists because environmental stimulation alone cannot account for the speed and proficiency in which children acquire language. Beginnings and people of contemporary cognitive psychology. We have George Miller argues that a symposium of information theory sponsored by MIT marked the beginning of modern cognitive psychology. He continued to move the interest in cognitive psychology along with several contributions. Miller and Brunner founded the Center for Cognitive Studies, through which Piaget's ideas were popularized in the United States. You may recall that George Miller was one of the key figures that did a lot of research in the area of memory, particularly the ideas of short-term memory, for example, how much it can contain. Lashley and Hebb continue to discuss physiology and behavioral phenomena in cognitive processes. Leon Festinger noted that the ideas that one may have might be compatible with or incompatible with one another. When ideas are incompatible, a state of cognitive dissonance exists that motivates a person to change beliefs or behavior. His description made no reference to behavioristic ideas. Leon Festinger could be sort of seen as a social psychologist, but the idea here, he was saying that ideas that one possess, attitudes that they hold, sometimes they can be in conflict with one another, and it causes a sort of tension, a dissonance in the organism, which causes them to have to change something to get back in balance. Hebb, his APA presidential address urged the use of the scientific rigor of the behavioral researchers to study cognitive processes. He noted the work of Festinger and Miller, Galanter and Pembroke as good starts toward the rigorous cognitive psychology. He was also encouraged by the possibility of using computer models for studying cognitive processes. Ehrlich Nesser, cognitive psychology, and Bandura, his social cognitive theory, began its early development and is still a popular theory in use today. So what we see with all this work and thought about the cognitive aspects of our lives, we're part of this cognitive revolution. Then we have the idea of artificial intelligence, a special branch of computer science that investigates the extent to which the mental powers of human beings can be captured by means of machines. Alan Turing and the Turing test. Alan Turing raised the question about and developed a test of whether or not machines think. Other researchers have suggested the concepts of weak artificial intelligence and strong artificial intelligence. Proponents of weak AI claim that, at best, a computer can only simulate human mental attributes. Proponents of strong AI claim that the computer, when appropriately programmed, really is a mind capable of understanding and having mental states. Now let's revisit Descartes, the Cartesian challenge. Following up on his mechanistic views, if there were machines which bore a resemblance to our bodies and imitated our actions as closely as possible for all practical purposes, we should still have two very certain means of recognizing that they were not real men. The first is that they could never use words or put together signs as we do in order to declare our thoughts to others. Secondly, even though some machines might do some things as well as we do them, or perhaps even better, they would inevitably fail in others, which will reveal that they are acting not from understanding, but only from the disposition of their organs. Hence, it is for all practical purposes impossible for a machine to act in all the contingencies of life in a way in which our reason makes us act. So Descartes had a lot of serious thoughts about these ideas of what we would refer to as artificial intelligence. So it leads to some empirical and conceptual questions. The Turing test. Can a machine meet the Cartesian challenge? That is, use language in a way that humans do rather than merely uttering sounds. Exhibit the complexity and flexibility of behavior in a wide range of areas as humans do. What, if anything, of philosophic interest would it show if a machine could pass the Turing test? Is passing the test necessary for intelligence? Is passing the test sufficient? What is a machine? Aren't our brains themselves machines? So the Turing test was basically based on this idea of the Cartesian challenge. If you have a conversation with a machine and it's hidden from you, so you don't know if it's a person or machine, will you be able to say, no, I'm talking to a machine? Or will you be able not to be able to distinguish a real live human being from a programmed machine or artificial intelligence? That is in essence what the Turing test is about. So let's go back to this idea of functionalism, which we've discussed previously. Functionalism. Mental states are to be characterized in terms of their causal relations to sensory inputs, behavioral outputs, and other mental states, that is, in the terms of their functional role. A Turing machine can do this. So if functionalism is true, a machine should, in principle, be able to do anything a person can do. Can a machine do whatever a person can do? And can it meet the Turing test, the challenge? So we see a couple of examples here. What can people do that computers can't do? There is telling humans and computers apart automatically, or CAPTCHA. A CAPTCHA is a program that protects websites against bots by generating and grading tests that humans can pass, but current computer programs cannot. For example, humans can read distorted text as the one shown below, but current computer programs can't. The term CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. It was coined in the 2000 by Louis van Ahn, Manuel Blum, and others to sort of give a shout out in a sense to Turing, but also do something that was very much needed at the time. Computer programming is to a point now where computer programs can be utilized to attack websites by sending in queries, by sending in requests for information, which can then bog the website down and make it useless to anyone else who's attempting to use it. So that's why CAPTCHA came into existence, a way to make sure that it's not a bot trying to make some sort of request from a particular website, but an actual human being. Because the bots or the programming is unable to distinguish the curvy lines and the funny shapes to be able to point out or pluck out the letters of the words there, but humans can. So the imitation game. Turing proposes a game to which we can imply how we could use this Turing test. Turing proposes a game in which we have a person, a machine, and an interrogator separated from the other person and the machine. The object of the game is for the interrogator to determine which of the other two is the person and which is the machine. So the idea is that you have this interrogator asking questions of these people hidden from his sight. And from the questions that they ask, and from the responses that the individuals, quote, individuals give back, they should be able to distinguish the person from the machine. You are successfully passing the Turing test in this imitation game if the machine can fool the person. We see some aspects of this today. We know sometimes that robocalls, machines call us for a variety of reasons. And sometimes as we're speaking to them, we're not quite sure if we're talking to a live person or not. So we see that there are attempts to try to make it such that we have AI. Okay, or at least we can interact with a machine in such a way that it may be difficult for us to determine whether or not we're talking to a machine or not. We even see it today in our homes with systems such as Alexa or Siri on our phone, where they try to speak to us in a very conversational way. Now, artificial intelligence, not everyone agrees with the idea that we will be able to achieve this artificial intelligence. Serial argument against strong AI. Serial distinguishes between syntax, the manipulation of symbols according to specified rules, and semantics, assignment of meaning to symbols. So syntax, the manipulation of symbols, and semantics, assignment of meaning to symbols. He stated that computer programs have syntax, not semantics. Human thought has intentionality, but computers do not. So he offers up this argument against strong AI. A thought experiment by John Searle and associated derivation. It is one of the best known and widely credited counters to claims of artificial intelligence. That is, to claims that computers do, or at least can someday, might think. Machines don't think, they simulate thinking, no matter how good the simulation may be. So the idea that he proposes is the notion that you could have a machine that has been programmed with all sorts of responses. If they get X response, they'll be able to say, if they get X input, they'll be able to say X whatever response to that input. It's just syntax, structured way to get input. This is the output or response I give to it. So they use this idea of the Chinese room argument that we could program a machine to act as if it understands the Chinese language. But all it really is ever going to be able to do is to simulate that, simulate thinking and understanding the language. Because we program it, if you get this input, this is the output you send back. And so we sort of see this when we deal with our Alexas in our series, because what we know is that sometimes we can really confuse them, but they're sending back some version of a canned response. So, artificial intelligence, are humans machines? The question reintroduces important questions into modern times, such as what is the nature of human nature? This type of question posed in relation to machines brings into play many issues such as the mind-body question and the lawfulness of human behavior and free will. So all of this sort of introduces us to the ideas of cognitive psychology, how cognitive psychology sort of came back on the scene after the major behavioristic movement in the United States. But now let's introduce this idea of cognitive science. The approach of cognitive science uses the computer as a model for human information processes. It follows the rationalist tradition, has a strong nativistic component. Faculty psychology, information processing, marks a return to faculty psychology, as does the recent discovery that the brain is organized into many modules or groups of cells, each associated with some specific function, which then returns us to the mind-body problem. Radical behaviorists deny the existence of the mind, but cognitive psychology assumes the existence of a mind. In each case, bodily events and cognitive events are assumed. Therefore, the relationship between the two must be explained. Cognitive science. In the 1970s, information processing psychologists combined efforts with philosophers, anthropologists, linguists, neuroscientists, engineers, and computer scientists to create the area of cognitive science in the 70s, where they began to ask some of these questions. Questions that we began talking about when we talked about the philosophy of the mind many chapters ago. So in a way, we're sort of coming full circle, back around to where we started off earlier in this course.